we can say a motor is a dynamic machine. Okay, so let me check which questions we are going to cover today. Okay, so question number 4. Okay, question number 4. What is the question? That list out and explain different type of losses in a DC machine. How these losses can be minimized. So this question has been asked for a 6 mark in November 17 examination. Okay, so we will see that question, losses of a DC motor. Yeah, first thing, as I told you, that DC motor is a machine which having some kinds of losses while it is in operating condition. So as yes, so as current is flowing through the armature as well as field winding, so due to the current there is a copper losses. Okay, so we know that the formula for copper losses is Ia square Ra. So if there is a current flow, then there is a copper losses. So first thing you should understand that in armature winding as well as field winding there is a flow of current. So copper losses are present in both winding, that armature as well as field winding. Then that current is always in alternating in nature, so that's why it is alternating continuously. So due to that, whenever this current flowing through the core, at that moment eddy current as well as hysteresis losses will take place, which is also known as a magnetic losses as well as core losses. Whose mic is on? Please mute yourself, you are disturbing the whole class. Due to that current flow in armature as well as field winding, there is a copper loss, and also due to the continuously alternation of current, there is occurrence of eddy current as well as hysteresis losses, which eddy hysteresis loss which is due to the residual magnetism, and these both losses comes under the core losses. That means iron losses. So already we have discussed in a generator, that is copper losses mean variable losses. Why we will say that variable losses? Because whenever our current is going to change, at that time our copper loss will be changed. Okay, because our copper loss fully depends on the current value. So that's why we use that word variable losses for the copper losses. Now second thing, iron losses. That iron losses, there is no change in magnetic properties of the core, so that's why there is a eddy current losses and hysteresis losses, which are constant losses. Due to that, that iron losses is known as constant losses. And last one, as the motor having a rotational part, there is a rotor as well as stator. So due to that, there is a rotation of rotor or conductor. Then there is a friction. That's why due to the friction, the losses which is occurred is known as frictional losses. And sometimes there is a air gap between stator and rotor. So in that air gap, due to the wind or due to the external air, there is some kind of losses. Okay, so that losses are known as a windage losses. Okay, so here two equations I have put in. That yesterday's lecture we have seen that mechanical power developed is equal to VIA minus IA square RA. Okay, that is the equation for the mechanical losses, which we have calculated by the uh, EB is equal to V minus IA RA. That equation, when we have multiplied by IA to the both side of the equation, then we got EB. I will write here that equation. I think you will remember that EB is equal to V minus IA RA. So what we have done, we have multiplied by IA to this side, IA to this side, and IA to this side. So it will become EBIA. EBIA means our mechanical power. Then VIA is nothing but as it is, and IA is we become IA square RA. So that's why the mechanical power developed we have calculated by using the formula PM, that is mechanical power, is equal to VIA. VIA means the power, electrical input, and minus IA square RA. Minus IA square RA means voltage drop across the armature winding. And one more thing, we have seen that maximum power will occur, or maximum power we will obtain at the condition when back EMF is half of the voltage. back EMF is equal to half of the voltage. Okay, so that things we have seen. Now we will move forward in the power flow direction. Okay, so as we have seen in a generator, there is also power flow. Okay, in generator, input was the mechanical and output was the electrical, but in case of the motor, power flow will be like electrical to mechanical. Okay, so first thing, that is electrical power input, that is a P in. Okay, so whenever our P in will come to the picture, at that time there is some copper losses. PCU is denoted by the copper losses. Then PB means what? There are brushes in the motor, so that's why there is some kinds of brushes drop. So brush drop will be considered as a brush loss. Okay, so that variable losses, power copper loss as well as brush loss, which is considered as a copper variable losses. So P in minus copper losses. Then rotational losses. Rotational means what? Mechanical losses. Mechanical means that PFW means losses due to the power of losses which is due to the friction as well as windage. Okay, the next one is a stray losses. Okay, stray losses means what? As a mechanical properties are there as well as magnetic properties of the core are there. So that's why stray losses will occur. And core losses means what? Hysteresis as well as ED current losses. So these all losses are fixed. That means constant losses. Okay, and then after P output is equal to power at shaft. Okay, so this is the power flow study of a DC motor, where power input is equal to input power is nothing but what? That electrical input, which is V into IA. Okay, this is equal to V into IA. And one more thing, that mechanical power will develop, that is a EA into IA. Now P in minus PCU minus PB. See, I will write here this minus these all terms. That means input power minus variable losses will become the mechanical power developed. Now this mechanical power developed also not a final output. It is also required to subtract the rotational losses, that is a constant losses from the mechanical power developed, so that we get power at the shaft end. Okay, so this is the power flow diagram of a DC motor. Okay, so now that losses which we have seen in this slide, that copper losses, armature copper losses, field copper losses, iron losses again classified hysteresis, eddy current, then mechanical losses classified into friction as well as windage. So that losses we will see here in detail one by one. So firstly we will take a copper loss. Okay, so copper loss means what? Whenever there is a winding, then there is a copper loss. Means what? If in any winding current is a flowing, at that time some kinds of heat is there. So we know that formula for the heat is I square R. Okay, I square R. That means if any winding is there, then this winding having a resistance value, and if the current flowing through this winding, at that time that resistance will get multiplied by the current value, and that much amount of heat will get dissipated. So this is nothing but what? Copper loss. Okay, so actually whatever resistance value for the winding is there is mostly depend on the frequency as well as the flux conditions. Okay, so if there any difference between computed and actual copper losses, then this comes under the stray loss category. Okay, so that means what? If there is a winding, suppose we will consider there is a copper winding in a motor. So once that copper winding having some kinds of resistivity. Okay, now whenever we will allow to flow a current, at that time this current will flow through the winding. Then we know that if there is a resistance, then current flowing through the winding, then there is a voltage drop. The drop means what? It will dissipate into heat, and this heat is nothing but what? Copper loss. Okay, so if this current will change, then this losses will also change. That's why it is known as a variable losses. Now next one is a brush losses. So there are two brushed or two types of brushes which is used in a DC motor. The first one is a graphite, that means carbon or metal graphite. Okay, so this type of question will be asked into multiple choice questions. That is brushes are used in a DC motor are made up of. So there may be one option as a graphite or a carbon. Okay, so keep in mind that carbon or graphite both are same things, and also another one metal graphite which can be used for the brushes purpose. So in both cases of the brushes, both having the resistance, and due to that resistances of brushes there is a dissipation of a power. Okay, so generally brush drop voltage or brush voltage drop will be considered constant as a 2 volt, okay, for graphite, and 0.5 volt for a metal graphite. Okay, so this question will be also asked for the MCQs, that brushes are assumed to have a constant voltage drop across them dash dash holds for the graphite brushes. So there may be an option that is a 2 volt. So you just understand or keep in mind, for the graphite brushes there is a 2 volt constant voltage drop, but for the metal graphite there is a 0.5 volt metal graphite brushes. Okay, so this is the brush losses. Why brush losses are considered? Because there is a resistances in a brushes, so that's why it is considered as a brush losses, because power dissipation is there. Next one is a mechanical losses. So in that losses, mechanical means what? The losses which is occurred due to the mechanical part of DC motor. So now what is the mechanical part? The mechanical part is a rotor. Okay, the mechanical part is a shaft. Okay, so due to that mechanical part, whatever the losses will praise occurred, that means a friction loss as well as windage loss. Okay, so if there is a rotor as well as shaft, then there may be a bearings. Okay, so to rotate that rotor in a smooth way, there is a bearings, and due to that bearings, there may be a whatever we can say, there may be a friction. Okay, so that energy is dissipated in turning the rotor through the air inside the machine. So we know that there is an air gap between rotor and stator of the DC motor. Air gap means what? A little bit amount of space is there. So this space is sufficient to flow some amount of air. Due to that air there is windage losses also. So to find out that mechanical as well as frictional losses or rotational losses, we can determine by using one experiment where we have to rotate, or we have to run our machine at a rated speed without any load. Okay, without any load or excitation. So that time we will find out the rotational losses. Okay, then next one is a open circuit. Open circuit means what? There is a no load. Open circuit is nothing but what? There is a no load. That output terminals are open, so that means there is a no load. Hello, I am audible. Otherwise, I am just speaking and speaking, and you guys may not listen anything. Am I audible now? Yeah, fine, fine, fine. Thank you. So, in case of open circuit losses, or we can say why this is known as open circuit, because two terminals at the output side is has been opened. That means there is no load. So that's why these open circuit losses are can be considered as a no load losses. So if we have to measure that constant losses, which constant losses? That hysteresis loss as well as ED current loss. So whenever we need to measure that two losses, or we can say that magnetic or core losses, then and only then we can use that open circuit or no load measurement method. Means what? जर आपल्याला कॉन्स्टंट लॉसेस जर मेजर करायचे असतील तर आपल्याला लोड देऊन चालत नाही, कारण लोड जर दिला तर तुमचा करंट हा कमी जास्त होणार आहे बिकॉज ऑफ लोड, आणि त्याच्यामुळे तुमचे कॉपर लॉस हे व्हॅरिएबल असल्यामुळे तुम्हाला फाइंड आउट करता येणार नाही. सो तुमचा कोअर लॉस फाइंड आउट करण्यासाठी तुमच्या मशीनवरती काहीही लोड नसला पाहिजे, अँड देन अँड ओनली देन यू कॅन फाइंड आउट or you can determine the core losses due to the hysteresis as well as ED current. So okay, so maybe there is due to the armature reactions, there is a increase in core losses, as well as the difference between the measured and actual core losses will comes under the stray loss category. Okay, so as we have seen that copper losses, mechanical losses, brush losses, opens losses. Last one I think there is a stray losses. Okay, So in stray losses means what? It is a constant losses and प्रत्येक मशीन वरती स्ट्रे लॉसेस हे डायरेक्टली इन पर्सेंटेज दिलेले असतात. इफ सपोज देर इज अ 10 किलोवॅट मोटर, then there is a 0.1 kilowatt or 100 watt losses are considered for the motor as a stray losses. Okay, so here you can see by convention stray load losses are considered to be 1% of a rated output फॉर अ डीसी मशीन. मीन्स व्हॉट? डीसी मोटरचे जी काही आउटपुट असेल, सपोज 5 HP ची मोटर असेल तर 5 HP मोटरमध्ये 1% लॉसेस हे स्ट्रे लॉसेस पकडलेले असतात. ठीक आहे. सो दिस इज ऑल अबाउट दी losses. Okay, so if anybody any doubt, please let me know, so we will finish the losses and we'll go for the efficiency. So any doubt in losses? Okay, one response. Anybody else? At least from 35 students, 4 to 5 students at least represent that, sir, no, we have no problem, or sir, yes, we have that problem. Not I cannot judge by a single person if he is saying no. Okay, so rest of us, tell me, is there any problem, any doubt in a losses of DC motor? Hello, direct second year students. आज DSY नाहीत का? ऍक्च्युली मी स्क्रीन शेअर करत असल्यामुळे मला पार्टिसिपंटची लिस्ट पाहता येत नाहीये. So that's why I'm not able to see the participants list. So that's why I'm not able to also see direct student DSY students names. So please DSY students reply. Any doubt? Very good. Okay, then we will go for the efficiency. Now first thing, just a minute. Okay, so in case of efficiency, the first statement is that efficiency is nothing but the ratio of output to the input, right? Am I right? Efficiency is nothing but what? Ratio of output to the input. Okay, now if suppose we have the supply voltage of a DC motor is V. Okay, what is the voltage value? It is, we will consider capital V. And if motor is drawing I amount of current or I ampere, then the input power to the motor as per our formula, that voltage into current is equal to power, we got input power is equal to VI. Clear इथपर्यंत? आर यू गाईज क्लिअर? क्लिअर असाल तर सांगा, म्हणजे मला कळतं की तुम्हाला इथपर्यंत समजलं, याच्या पुढे जाऊ शकतो. हा, गुड. नाव as we have seen, what we have seen? We have seen the power flow diagram. So in that power flow diagram, I will show you. See, just let me erase all the things. Yeah, so here P in we have find it out, that is a V into I. Now आपल्याला हे पीडी म्हणजे थोडक्यात त्याला पीएम म्हणा, म्हणजे मेकॅनिकल पॉवर. ही पॉवर कधी भेटते आपल्याला? जेव्हा ह्या इनपुट पॉवर मधून हे जे कॉपर लॉसेस आहेत ते आपण जेव्हा मायनस करेन, तेव्हा आपल्याला हे काय मिळते? मेकॅनिकल पॉवर. पहा आता इथं आहे का तसं? सी, आफ्टर कॉपर लॉसेस दॅट आर्मेचर डेव्हलप्स द मेकॅनिकल पॉवर इज इक्वल टू EB into IA. ओके, लक्षात येत आहे का? मेकॅनिकल पॉवर विल बी EBIA. आता परत पुढे जायचंय आपल्याला काय फाइंड आउट करायचंय? परत मी मागच्या डायग्राम कडे येतो, परत ह्याला इरेज करतो. हा, नाव वी आर दॅट स्टेज, दॅट इज नथिंग बट अवर PM. नाव दिस इज अ P आउट. ओके, P आउट कधी भेटते? व्हेन that all losses, that's rotational losses or the, we can say, mechanical losses, once we will subtract from this mechanical power, then we got P out. So I will write simply here, P out is equal to PM minus these losses, right? बरोबर का? लक्षात येतं का तुमच्या? पॉवर फ्लो डायग्राम वरून इफिशियन्सीचे इक्वेशन्स कसे लिहायचे? पहिल्यांदा काय केलं, आपल्या मोटरचं इनपुट काय असतं, आपल्याला दोन गोष्टी काढायची. इफिशियन्सी म्हणजे आपल्याला दोनच गोष्टींकडे जायचंय फायनली, एक इनपुट पॉवर, दुसरं आउटपुट पॉवर, बाकी काहीच गरज नाही. पण आता ह्या गोष्टी कशा फाइंड आउट करणार, तर इनपुट पॉवर फाइंड आउट करण्यासाठी आपल्याला माहिती पाहिजे मोटरला किती सप्लाय देतोय आणि मोटर किती करंट ड्रॉ करते. तर आपल्याला माहिती आहे मोटरला आपल्या व्होल्टेजचा सप्लाय आहे व्ही आणि आपल्या मोटरने ड्रॉ केलेला करंट आहे आय. सो इनपुट पॉवर इज व्ही आय. सी हिअर. देन आपल्याला माहिती पाहिजे आता इनपुट पॉवर जशी दिली तशीच पूर्णपणे आपल्याला मेकॅनिकल पॉवर मिळणार आहे का? नाही मिळणार. कारण का, तर तिथं थोडेफार हे कॉपर लॉसेस असतात. तर ते कॉपर लॉसेस आपल्याला काय करावे लागतील, इनपुट पॉवर मधून सबस्ट्रॅक्ट करावे लागतील. सो वन्स we will subtract that p in minus all the variable losses or copper losses, then we will get mechanical power, and mechanical power is equal to back EMF into armature current, or the voltage developed in armature circuit into armature current, that is a mechanical power. आता इथं परत मेकॅनिकल पॉवर जी डेव्हलप होते ती आपली आउटपुट पॉवर झाली का? नाही. कारण जर आपली मेकॅनिकल पॉवर जनरेट झाली, आपला शाफ्ट फिरायला लागला, तर आपल्याला परत जे कॉन्स्टंट लॉसेस आहेत, जे फ्रिक्शनल लॉसेस आहेत, विंडेज लॉसेस आहेत, कोर लॉसेस आहेत, ते लॉसेस परत मायनस करावे लागतील. म्हणजेच after the friction windage loss, the mechanical power appearing at the shaft. So final power where we are getting at shaft. This mechanical power is appearing at armature circuit. But we need to find out the power appearing at the end of shaft. So this is nothing but P out is equal to PM minus WC. Now this WC is nothing but what? That all losses. That all losses, ह्या सगळ्या लॉसेस साठी काय नाव दिलं मी, एकच, WC. So WC is equal to PFW plus P spray plus P core. Okay, so for simplification I have taken that P out is equal to mechanical power minus all the rotational or constant core losses. Now I think you are clear. Okay, इथपर्यंत कोणाला काही डाऊट? एनी डाऊट? ओके फाइन. नाव आता आपल्याला काय करायचंय, अप्रॉक्सिमेट इक्वेशन फाइंड आउट करायचं. काय करायचंय, अप्रॉक्सिमेट इक्वेशन फाइंड आउट करायचं. आता पहा, मी थोडस तुम्हाला पाठीमागे घेऊन जातो पहिल्या स्लाइड वरती. हिअर इथं इलिमिनेट करू द्या इरेज. हा, इथं पहा, हे इक्वेशन आपण काल पाहिलेलं आहे. PM इज इक्वल टू मेकॅनिकल पॉवर इज इक्वल टू काय बघितलं आपण, VIA मायनस IA स्क्वेअर RA. लक्षात आहे का हे कसं काढलं होतं, कोणत्या इक्वेशन वरून काढलं होतं? EB इज इक्वल टू V मायनस IRA. आठवतंय का? अरे लक्षात येतंय का? मी एकटाच बडबड करतोय, तुमच्या लक्षात येतंय नाही येतंय मला नाही माहिती. कारण हे पहा, आपण काल एक इक्वेशन पाहिलं होतं, मी पुन्हा एकदा इथं रिपीट करतो. तुम्ही रिस्पॉन्स नाही दिला तर मला नाही समजणार तुम्हाला कळतंय का नाही कळत. ओके, सी इथं आपण पाहिलं होतं काल, EB इज इक्वल टू V मायनस IA RA. ओके, नाव आपण काय केलं होतं, प्रत्येक टर्मला IA ने मल्टिप्लाय केलं होतं. जर इथं IA ने मल्टिप्लाय केलं तर काय येईल, IAEB VIA आणि इथं होईल स्क्वेअर. आता हा IAEB म्हणजेच कोण आहे पहा, आपला IAEB म्हणजेच कोण, PM. सो आपण लिहूया इथं PM इज इक्वल टू हा VIA ॲज इट इज ठेवूया, VIA मायनस पुढं काय आला, IA स्क्वेअर RA. ठीक आहे, म्हणजे आता आपण इथं P आउट इज इक्वल टू WC. तर या PM च्या जागी हा फॉर्म्युला टाकू शकतो ना, VI मायनस IA स्क्वेअर RA. ओके, तर पहा इथं आता आपण काय केलं, याच्या PM च्या जागेवरती कोणता फॉर्म्युला घेतला, VI मायनस IA स्क्वेअर RA. आता मला पटकन 2-3 जणांनी रिस्पॉन्स द्यायचा आहे. हे VI मायनस IA स्क्वेअर RA कसं घेतलं कळालं का? ओके फाइन. Okay, very good. Yes. Now see, the main equation that approximate power equation P out, as it is equation we are taking as it is, so we have just replaced that value of PM, and again WC is as it is. So again there are two losses we have not considered for that equation. आणखी दोन टाईपचे लॉसेस आपण इथं पकडले नाहीत, ते कोणते? तर ते लॉसेस कोणते असतात, तर आपले जे कॉपर लॉसेस आहेत ते शंट आणि सिरीज, म्हणजे परत टाईप आले, येते का लक्षात? परत डीसी मोटरचे टाईप आले, शंट मोटर, सिरीज मोटर. शंट म्हणजे काय, तर शंट फील्ड मधले आपण जे लॉसेस असतात कॉपरचे ते पकडलेले नाहीत. फॉर दी सिम्प्लिफिकेशन पर्पज वी विल कन्सिडर ओनली दॅट पी आउट इज इक्वल टू VI मायनस IA स्क्वेअर RA मायनस WC. आता पहा, इफिशियन्सी साठी मी काय सांगितलं, आउटपुट डिवायडेड बाय इनपुट. आपल्याला इनपुट माहिती आहे VI, आउटपुट माहिती आहे आपल्याला VI मायनस IA स्क्वेअर RA मायनस WC. तर आपण आता काय करू शकतो, इझिली efficiency find out करू शकतो. So we will go for the efficiency. Now overall efficiency of DC motor, see here, as I told you the formula P out divided by P in. So P out, P in, clear? Ratio of output power to the input power is nothing but efficiency of or overall efficiency of DC motor. लक्षात येतंय का? ओव्हरऑल इफिशियन्सी कळाली सगळ्यांना? हा, आता आपण काय करूया, इलेक्ट्रिकल इफिशियन्सीला जाऊया. आता इलेक्ट्रिकल इफिशियन्सीला जाण्याच्या अगोदर मी तुम्हाला काय दाखवू इच्छितो की पॉवर फ्लो डायग्राम. म्हणजे इथं तुम्हाला कळायला पाहिजे की इनपुट काय आहे आणि आउटपुट काय आहे, म्हणजे इफिशियन्सी फाइंड आउट करायला इझी होतं. आता पहा, इलेक्ट्रिकल काढायचंय म्हणजे हा एवढा पार्ट कन्सिडर करायचा, ठीक आहे. आता इथं इनपुट कोण आहे, पी इन, आणि आउटपुट कोण आहे इथं, पी एम, मेकॅनिकल पॉवर डेव्हलप्ड इन आर्मेचर सर्किट. बरोबर का? लक्ष देते का मी काय बोलतोय? इलेक्ट्रिकल इफिशियन्सी जर फाइंड आउट करायची असेल तर तुम्हाला दोनच गोष्टी कराव्या लागतील की इनपुट काय आहे आणि आउटपुट काय आहे. तर इलेक्ट्रिकल इफिशियन्सी काढताना इनपुट हे तुमचं इलेक्ट्रिकल असणार आहे, दॅट इज द पॉवर इनपुट इज इक्वल टू V इंटू IA, आणि आउटपुट हे असणार आहे तुमची मेकॅनिकल पॉवर डेव्हलप्ड इन आर्मेचर सर्किट. Now in armature circuit power is developed is equal to EB into IA. So we'll come to the our current slide. See, that is nothing but mechanical power divided by input power. Okay, so electrical efficiency can be calculated by using the formula the ratio of armature or ratio of the mechanical power developed at a armature circuit to the input of electrical power. So the equation will like EBIA divided by VI. Everyone clear? Overall efficiency, electrical efficiency. Any problem? Okay, good. Now last one is a mechanical efficiency. Okay, now again we'll go for the power flow diagram. This power flow diagram will play very important role, you can see, while calculating the efficiency. Now we need to find out the mechanical efficiency, means what, this efficiency. Okay, now here you have to find out the input and output. So someone tell me what will be input, another one will tell me what will be the output. Who will tell me what is input for the mechanical efficiency calculation? What will be the input? Yeah, very good, very good. Mechanical power developed in, yes, mechanical power is a, that is a PM is a input and output is P shaft or a P out. Okay, that will be output. Yes, P output or P shaft, which is both are equal, so that's why output will be that. So it's very nice to learn, hear from you guys. Okay, so see here, mechanical power, mechanical efficiency, that is a P out divided by PM. Now you can see one thing, whenever this efficiency is writing, see here, overall efficiency, it is written by NC, electrical efficiency denoted by NE, and mechanical is denoted by NM. So do not confuse. Okay, so all are efficiency, but once you find out the electrical efficiency, mechanical efficiency, then it is very easier to find out the overall efficiency. Why? Because see, in electrical efficiency, whatever the input in P in, that will be here P in, and whatever be the output in mechanical will be here out. Okay, now we'll go for the mechanical efficiency of a DC motor. Now see, we have value for the P out. What is the value for P out? Already we know P out is equal to VI minus here VI minus IA square RA minus WC, and P mechanical is equal to EB into IE. Okay, now one more thing, we know that we know that first thing we should clear why this mechanical efficiency is necessary to determine. Why? Because we need to know that how efficiently or how properly our motor is delivering armature power to the shaft of the mechanical shaft of the machine to do some mechanical work. Okay, so we can easily say that is the ratio of the mechanical power output to the armature power. Okay, so now see, if we consider that I is equal to IA little bit amount, then see that EB is elaborated like EB. What is the value for EB? I will write here EB is equal to V minus IA RA. So this value is written here. Okay, only the value change or substituted. Okay, now what we will do? We will multiply this IA to the particular term. So it will become VIA minus IA square RA. Okay, now we can take a common term from this, that means 1 minus WC by C here. ओके, इथपर्यंत कोणाला काय डाऊट आहे का इक्वेशन मध्ये? इथपर्यंत कोणाला काय डाऊट? कळालं का इथपर्यंत? ओके, आता पुढे जाऊया आपण. पुढे केल्यावरती काय पहा, आता वरती तुम्हाला एक सेम टर्म दिसेल व्ही आय ए मायनस आय ए स्क्वेअर आर ए, खाली पण तुम्हाला तीच टर्म दिसेल. सो आपण त्या टर्मला काय करू शकतो, कॉमन काढू शकतो. सो सी हिअर पहा, वरती काय केलं आपण, एक टर्म कॉमन काढली. ओके, म्हणजेच काय, जर आपण फील्ड करंटला नेग्लेक्ट केला तर जो तुमचा आर्मेचर करंट आहे तोच तुमचा सप्लाय करंट असणार आहे. सो द एक्सप्रेशन फॉर द ओव्हरऑल एफिशियन्सी विल बिकम as 1 minus, see here, VIA minus IA square RA minus WC. Okay, so 1 minus WC upon VIA plus IRA divided by V. Okay, so this will be the value of a simplification of the equation. Okay, so what we have did, we have only replaced the value of the back EMF with in equation V minus IARA. V minus IARA ने आपण व्हॅल्यू रिप्लेस केली, त्याच्यानंतर जो ब्रॅकेटच्या बाहेर IA आहे त्या IA ने आपण त्याला काय केलं, मल्टिप्लाय केलं. ओके, त्याच्यानंतर काय केलं आपण, तर जो तुमचा IA स्क्वेअर RA आहे त्याला आपण काय केलं, निग्लेक्ट केलं. ओके, का निग्लेक्ट केलं? कारण जो फील्ड करंट आहे तो जर आपण निग्लेक्ट केला तर आपल्याकडे जो काही आर्मेचर करंट आणि सप्लाय करंट राहणार आहे शिल्लक, ते दोघही काय असतात, सेम असतात. दॅट्स वाय वी हॅव neglected that one. Okay, now we will go forward. So this VI there will be 1, then minus IA square IA 1 IA will get cancelled for this. So IRA divided by only V plus WC divided by IA V. Okay, neglected the shunt field current. If shunt field current is neglected, okay, I will show you. See, this is a field, this is armature, and this is our voltage, DC voltage. Okay, now this is a shunt field current, this is a armature, this is a, okay, armature, and this is a line current, this is a armature current. Now tell me, जर हा करंट जर आपण नेग्लेक्ट केला, then this I will become IA. म्हणजे जेवढा I असणार आहे तेवढाच IA असणार आहे. That's why we have neglected that current and simplify the equation for the overall efficiency of a DC motor. Now it is time to calculate the condition for the maximum efficiency. Okay, now we have the equation. आता पहा, मॅक्झिमम कधी यायला पाहिजे, ही जी टोटल व्हॅल्यू आहे, ही जर व्हॅल्यू आपली टोटल आपण हिला जर डेरिव्हेटिव्ह घेतला आणि विथ रिस्पेक्ट टू आय ए, then it will be compared to the zero. Okay, so that one will be derivative will be taken or differentiated with respect to ia. So first differentiation, ra by v will be constant term, ia's derivative will be 1. Then in another circuitry there is wc by v is a constant term and 1 by x derivative will be, what will be derivative of 1 by x? 1 by x चं डेरिव्हेटिव्ह काय असतं? 1 अपॉन एक्स स्क्वेअर, सॉरी मायनस 1 अपॉन एक्स स्क्वेअर. सो सी, इथं तुमचा प्लस सिम्बॉल आहे, इथं खाली आला मायनस आणि तुमचा आय चा काय झाला? स्क्वेअर झाला. नाव अगेन this equation we got, so one side we can take to the left hand side or right hand side. So पहा, जर आपण मायनस wc, इथं मी लिहितो ra divided by v is equal to wc divided by v ia square. हा v गेला. ओके, म्हणजेच wc is equal to ia square ra. येते का लक्षात? इथला v इकडे गेल्यानंतर हा टर्म इकडे जाणार आहे, ती प्लसला गेली, त्याच्यानंतर हा v कॅन्सल होणार आहे. ओके, परत एकदा दाखवतो मी समजलं नसेल तर. पहा, इथं कोणती टर्म आहे? आर ए डिवायडेड बाय व्ही, आणि ती मायनसची टर्म पलीकडे गेल्यावरती काय झाली? डब्ल्यू सी डिवायडेड बाय व्ही इंटू आय ए स्क्वेअर. आता हा व्ही इथं डिवाइडला, हा इकडे मल्टिप्लायला आला, म्हणजे इथं आला व्ही, म्हणजे हा व्ही गेला. बरोबर, म्हणजे काय राहिलं? आर ए इज इक्वल टू डब्ल्यू सी डिवायडेड बाय आय ए स्क्वेअर. आता हा आय ए स्क्वेअर मी परत लेफ्टला घेतला तर काय राहिलं? आय ए स्क्वेअर आर ए इज इक्वल टू डब्ल्यू सी. ओके, आता मला एक गोष्ट सांगा की डब्ल्यू सी म्हणजे कोणते लॉसेस? तर डब्ल्यू सी म्हणजे कोर लॉसेस, जे की आपण इथं पॉवर फ्लो मध्ये मी तुम्हाला सांगितलं होतं. हे जे सगळे लॉसेस आहे त्याच्यासाठी काय वापरले आपण? डब्ल्यू सी. डब्ल्यू सी म्हणजे कोणते लॉसेस? फिक्स्ड लॉसेस. फिक्स्ड म्हणजे कोणते? कॉन्स्टंट लॉसेस. ओके, तर हे आले इथं आपले कॉन्स्टंट लॉसेस, म्हणजेच कोर लॉसेस. आय ए स्क्वेअर आर ए म्हणजे काय? आय ए स्क्वेअर आर ए म्हणजे काय? तर कॉपर लॉसेस. ओके, तर कॉपर लॉसेस म्हणजे कसले आले? व्हेरिएबल लॉसेस. म्हणजे एक तुम्हाला समजलं असेल की कंडिशन फॉर द मॅक्झिमम पॉवर, मॅक्झिमम इफिशियन्सी in a DC motor will occur at the situation when copper losses is equal to core losses, or we can say constant losses is equal to variable losses. लक्षात आलं का? मॅक्झिमम इफिशियन्सी साठी काय कंडिशन असेल? तर तुमचे जे व्हेरिएबल लॉसेस आहेत ते जेव्हा कॉन्स्टंट लॉसेसच्या बरोबर किंवा इक्वल असतील, then and only then there is a condition for the maximum efficiency. ओके, याच्यामध्ये कोणाला काही डाऊट असेल तर पटकन क्लिअर करा. एनी डाऊट? हॅलो. Okay, fine. So today's lecture we have